Good morning, 7th grade. Today we're going to review inequalities. Our learning intention is I am learning to solve two-step inequalities to solve problems, and our success criteria is I can write and solve two-step inequalities for real-world scenarios. Okay, first we're going to take a look at some vocabulary that we'll need. First, let's recall what an inequality is as opposed to an equality, right? An inequality is a mathematical sentence that shows the relationship between two quantities that are not equal. So for example, if we have an equality, we can have, let's say, 2 plus 3 equals 5, right? In this case, the equalities, the expressions on both sides of the equal symbol are equivalent, right? We have 2 plus 3, that equals 5, and then we have the constant 5, right? In this case, this is an equality. Now, with an inequality, the difference is that we're showing that the relationship between quantities that are not equal. Okay, so for example, here we can have, if we use constants, we can have 2 plus 3 is less than 7, right? In this case, we have two quantities. We have an expression on the left side, 2 plus 3, which is 5, and 5 is less than 7. This inequality statement is true because we know that 5 indeed is less than 7. Now we can also include variables in inequality statements, and this is what we're going to see today. Okay, and below are symbols, the meaning and the word phrases. So we have the symbol less than, okay, and what the meaning of this symbol is, that is less than, and keyword phrases to look for in word problems are fewer than or below, and we would know to use the less than symbol. Okay, greater than is the next symbol, and keyword phrases to look for here are more than or above. Then we have is less than or equal to. Okay, and this means that a quantity could be less than or equal to. So if we have something like x is less than or equal to 3, right? This, and we were to put it on a number line, okay? Here we have 3. If we were to graph this inequality, right, this would mean that the value of x is less than or equal to 3. So in this case, we can encircle the 3, and not only encircle it, but color it in, because x equals 3 is part of the solution, right? And then we would also have all the values that are less than. Okay, so we can shade it in, this part of the number line to the left, and this would be, this would represent x is less than or equal to 3. So remember, when we see that, this means that x is less than 3, but also it's also true that x is equal to 3. So we combine this in this symbol, less than or equal to. And again, key phrases to look for here is at most or no more than, right? And this indicates that we can use the less than or equal to symbol. And lastly, we have the greater than or equal to symbol. Okay, and keyword phrases to look for here are at least or no less than. All right. Okay, so let's continue reviewing some vocabulary related to inequalities. Okay, so the solution of the inequality x is greater than 2 is all numbers greater than 2, but not including 2. Okay, so we're going to go over the word constraint. An inequality such as x is greater than 2 represents a constraint. Okay, and a constraint is a condition that restricts the value of a quantity or variable to a given value or range of values. In this case, for the inequality x is greater than 2, all of the values of x must be greater than 2. So 2 and the numbers less than 2 are not solutions of x is greater than 2. And that constraint in this case, again, is what restricts the values of that quantity to a given value for that range of values. Okay. The solution of an inequality is a value or values that make an inequality true. And an inequality can have many solutions. All right. So for instance, in the above case, if x is greater than 2, the solution to that inequality could be the number 3, or it could be the number 4, or it can be 2 5/10, right? So we're seeing that an inequality can have many solutions. So let's take a look at this picture to the right. It says the constraint of this ride is that you must be 54 inches or taller. So let's express this as an inequality. Take a second to read the condition again, identify the constraint, and then represent this with an inequality statement. So I'm going to pause the video. So in this case, the constraint reads, the constraint of this ride is that you must be 54 inches or taller. So let's say we have a variable h that represents height. We know that the person going on this ride must be 54 inches or taller, right? So we can write h is greater than or equal to 54, because the height can include 54 inches, right? We can be 54 inches or taller. So this would be the inequality statement that represents this situation. Okay, now let's read this problem where we can apply what we've just saw regarding inequalities, constraints, and the different symbols that we can use depending on the context of the problem. So here we see a population study was performed to find the number of deer in 2 parks. The study found that twice the number of deer in Maple Park is at least 20 more than the number of deer in Smith Park. The study found that there are 50 deer in Smith Park. Write an expression to represent the difference between twice the number of deer in Maple Park and the number of deer in Smith Park. Use x for the number of deer in Maple Park. Okay, so we know that the problem is about deers and parks, and we're comparing the number of deer in 2 parks. So let's reread the problem, right? Reread the problem and identify the quantities that are going to be relevant to part A. So what the study found is that twice the number of deer in Maple Park is at least 20 more than the number of deer in Smith Park. Okay. Now, and the study found that there are 50 deer in Smith Park. So first we're going to write an expression to represent the difference between twice the number of deer in Maple Park and the number of deer in Smith Park. All right, so we know that the number, and we're going to use x, we're going to use x for the number of deer in Maple Park. Okay, well, we know the number of deer in Smith Park, right? We know that there are 50 deer in Smith Park. Okay. We know that twice the number of deer in Maple Park is at least 20 more than the number of deer in Smith Park. So notice that part A is asking us to write an expression that represents the difference between the number of deer in Maple Park, twice the number of deer in Maple Park, and the number of deer in Smith Park. So when we see that word difference, okay, that usually means that we can use minus, right, just to express that difference. So if we have twice the number of deer in Maple Park, so twice a number, and we have x for the number of deer in Maple Park, so twice that number would be 2x, right? And then the number of deer in Smith Park is 50. And we know that the difference, okay, the difference between the number of deer in this park, in these parks, is at least 20, but we'll leave that for later. For now, we're just going to follow part A and use the expression 2x minus 50, because this is the difference, okay? And part B is, what do you know about this difference? Okay, so we know that this difference, notice that, and here we're going back to the problem, the study found that at least twice the number of deer in Maple Park is at least 20 more than the number of deer in Smith Park. So remember, if we recall, when we see that key phrase, at least, right, if we go back, we know that at least, when we see that phrase, this means that we can use the greater than or equal to symbol. Okay, so we know that the difference is greater than or equal to 20. All right. And again, this is a positive 20 because we know there are 20 more in Maple Park, right? So they're going to be, well, when we say that twice the number of deer in Maple Park is at least 20 more than number. So in other words, 2x is going to be greater than 50 by the amount of 20. And another way of saying that is when we do part C, write and solve the inequality to determine the possible number of deer in Maple Park. All right, so we have two x minus 50 is greater than or equal to 20. Okay, so now we can solve this two-step inequality, right? Remember, our goal is to isolate the variable x. So our first step in this two-step inequality would be to add 50 to each side, right? And this I can do, remember, because of the equality, because of the addition property of of equality. So what I add to the left side, I can add to the right side. Right, so this would give me 2x is greater than or equal to 70. So now the second step is to divide each side by 2, right, to isolate the x. So I divide the left side by 2 and I divide the right side by 2. So then we have a solution to this inequality, which gives us x is greater than or equal to 35. Now, when I graph this solution, right, I can circle the 35, and since 35 is part of the solution because of the greater than or equal to, that equal to part of the statement enables us to circle the 35 as a solution, and also all the numbers greater than 35. Okay. So the second part of the question is, do all the values make sense? So think about that for a second. Do all the values make sense? Remember, we're talking about the number of deer. Okay, so if we have 35 deer, that's part of the solution set. That makes sense. 36 deer, that makes sense. Now, how about if we were to, select a number, let's say like 36 and 5/10. Right, 36 and 5/10 doesn't really make sense because we're talking about the number of deer and we can't have like half a deer in this case, right? So for this, only whole numbers make sense. Okay, so not all the values make sense, only whole numbers make sense. Now, what part 8, what does the solution of the inequality represent in this problem? What does this x greater than or equal to 35 mean? Right? What this means, remember we're talking about two parks, Maple Park and Smith Park. Okay, so we have, remember, x represents the number of deer in Maple Park. Okay, so what this means is that in Maple Park there are at least 35 deer. Okay? There are at least 35 deer, and so we applied what we know about inequalities in a real-world scenario. Okay. Now here are some practice problems for you to do. One is graphing an inequality. Another one is using an inequality, using inequalities to represent a situation involving a truck rental company. And the last one is using inequalities in a temperature problem.